Hey guys, I'm Christopher Tin. I am a senior data engineer over at OfferUp, and this is Glenn Park, also a data engineer at OfferUp. So before we get started, I kind of want to give you guys a quick overview of what OfferUp is. We are a mobile and web marketplace that connects you with trustworthy buyers and sellers nationwide. We have about 4 million daily active users right now, with about $90 million worth of goods sold each day. So the two words I really want to highlight from the previous slide is simple and trustworthy. In order for us to be a leader in creating a simple and trustworthy marketplace, we need to ingest data with as little friction as possible. Data is critical in our ability to make decisions. From validating that our end users still find it simple to use and navigate our ecosystem, to enhancing their experience by, you can see this feed here, by giving them recommendations for items that, are more aligned to their interests. On top of that, we need a lot of data in order to prevent crime and detect fraud to build that safety in our marketplace. With this in mind, it's kind of cool to think of data engineers such as Glenn and I as superheroes. But it also really highlights the impact data has on not only our business, but the brand itself. In short, a great measure of success for us is to design an architecture where we can always be able to absorb all the data. And with this, I'm going to hand over to Glenn to talk about design.
Thank you, Chris. FYI, I'm a terrible public speaker, so feel free to make fun of me after the talk is over. So with the goal of being able to pull and absorb all that data, we wanted to build a data ingestion solution that was scalable and could grow with our business. Using our company principles as a guide, we knew we wanted to build something very simple that's resource efficient in order to keep costs low and is scalable for the future. This allows us to become more focused on our customers rather than be concerned with engineering issues all the time. So we chose AWS because it had the right services to achieve the scalable solution that we were hoping for. So a large amount of the data that we generate is event-based. And so the architecture that we came up with to process and consume that data is based off of the dry principle, meaning don't repeat yourself, where we designed a solution that was reusable so that we could wrap it in an automation framework. So in this design, we kept it simple. Data from the mobile or web clients hit our backend EC2 servers, which fires an event to a Kinesis data stream. After that, Firehose will listen to that Kinesis stream and write it to an S3 bucket in JSON format, partitioned by subject, date, and time. After which, an Airflow job will copy that data into a Snowflake raw table maintaining that JSON format. Now, Snowflake is very efficient at querying JSON data, which enables us to structure it very easily using a view for our end users. And we chose Kinesis and Firehose because they provided an off-the-shelf streaming solution, which enabled us to get our solution up and running quickly with minimal effort. And from there, we decided on a combination of open source and third-party service providers for our ELT and data warehouse needs. So some of you might be asking, what is Apache Airflow? If you're not familiar with it, it is an open source workflow orchestration platform that we use for our ELT processes. It allows the authoring of workflows in directed acyclic graphs like that below there, which are comprised of tasks. So the modular architecture of the platform allows multiple tasks to be executed across any number of worker nodes in parallel. So that facilitates both horizontal and vertical scaling. It also affords significant coding flexibility with the support of Python, a large number of connectors, and the parameterizing of scripts using the Jinja templating engine. And then finally, as part of the open source Apache project, it has a broad support community and code portability for migrations into different tech stacks. Now, Snowflake, if you don't know what Snowflake is, it is a cloud-based, massive parallel processing data platform solution that's scalable with both storage and compute. So as our data footprint grows, Snowflake grows with us. Its architecture separates storage and compute, which allows repeatable design principles for scalability and resource isolation, and that helps us move toward our goal of automation. It also has some great components found in other SQL and NoSQL platforms, such as maintaining ACID compliance, so that even with multiple compute clusters querying the same data set, they don't step over each other. Let's see here. And another great NoSQL capability is its efficiency in querying JSON objects natively. So it's not as fast as a true NoSQL database, but it is faster than other competing products, which is why one of the reasons why we chose Snowflake. And by utilizing that variant data type to store that JSON as a foundation for raw data access, we can decouple application and data pipeline deployments, which really simplifies our workflows. So finally, it's 100% consumption-based, which means we're not using compute resources, and so we won't be billed for it with inactive periods. So in summary, Snowflake allows us to be extremely flexible in 3 of the 4 V's of big data: velocity, variety, and volume against cost. So looking back at the event pipeline and its scalability, as we generate more event types or as data volume increases, you kind of ask, how does it scale? Well, first, all the components involved are scalable. Every pipeline will have an EC2 backend source, Kinesis stream, Firehose, S3 destination, and a shared Airflow job to pull that data from S3 into Snowflake. And so if you're familiar with these AWS services, EC2 instances can be, instantly upgraded in place with more CPU and memory. Kinesis and Firehose streams can have extra shards added to them to add more parallel processing. S3 has virtually unlimited object storage with optional parallel processing for larger objects. And Airflow is actually installed on EC2 instances, so you can scale that both horizontally and vertically with more worker nodes as needed. And then Snowflake, underneath the covers, is actually AWS-based. Its storage is based on S3, its compute is on EC2, transitive property applies. So second point, the event pipelines are repeatable. So currently, if you look up here, we have an event pipeline that ingests events related to when a user creates an item listing. If we wanted to add another event type, such as an item edited event, we can simply create another Kinesis and Firehose lane to ingest that event with the same S3 target. And then we can once again repeat that process for another event type, such as like an item viewed event. So these separate pipelines for these separate event types allow us to tailor resources for each type's needs. So now that we have a design that's fully scalable, the question is, what's next? And I hand that off to Chris.
Okay, so now we have established a repeatable pattern. As you saw in that last slide, we just kind of repeat that same pattern. We can do it, right now we do it over 100 times. We repeat that pattern. But the next thing is, how do we automate the whole thing so that it can scale with our business while minimizing the resources needed, cost, people, time. So the first tool we used is Terraform. For those who aren't familiar with Terraform, it's a way to help write infrastructure as code. By giving our software developers the ability to write infrastructure as code as well as their regular service code, we can tie in the build together. And by doing a deployment, let's say we're deploying a new event stream, it will also go ahead during that deployment process in building and creating all the infrastructure needed for that new event stream, such as Kinesis data stream and the Firehose. One other really cool thing that we use is in Terraform is called source, module source. I'm going to put a little code snippet here. So this is an actual code snippet of what it looks like, of how we use it. It's not a real one, but it's a sample. But essentially, this is all an application developer really needs to know, because they don't know infrastructure as well as, let's say, our ops team. And we don't want them to maintain infrastructure because that's going to slow them down. So what we do is we use Terraform source modules to kind of say, here's a template. It's all in the source module. Just call it, put in your parameters, as you can see here, and that's all they need to do in maintaining their infrastructure as code with Terraform. The next thing I'm going to talk about, and this all will come together in the end, so bear with me here, is Avro, and particularly Avro schemas. So Avro is a data serialization framework, but one very key part about Avro is that it enforces strict schema when being serialized or deserialized. Now, JSON, on the other hand, is definitely not strict schema, right? And if you saw on the other slide, our whole entire pipeline, the message format we chose is JSON, which can become very problematic, especially with data types. So what we did is that we pulled out, we're using the Avro schema component of Avro and binding it with how we use JSON in order to do our own enforcement of schema on JSON. Now, of course, we can't do that in flight, so what we do is we put that in our CI/CD pipeline. So as we're running our test, we take a look at the events that are coming out of our services. Then we go ahead and validate that against the schema definition, as you can see right here, and make sure they match. While this doesn't really solve all data quality issues, it does get rid of the bigger headaches with data type issues and data type conversion issues. So that's why this is very important to us. Another really useful thing about Avro schemas is schema registries. I don't know if you guys have heard of them, but essentially you can upload your schema to a schema registry. It'll do versioning of the schema, and it also does something called schema compatibility checks to make sure that the next schema that you release is a non-breaking fix downstream. For me, as a data engineer, that is like heaven, right? Because so many times someone releases a change and doesn't realize that is breaking downstream processes where data types, the data type conversion can't be done. Okay, so lastly, we talked about Terraform, which handles kind of the AWS infrastructure automation part. We talked about Avro, which helps us maintain some kind of data quality with the event data coming out of our services, but we still have to automate Snowflake, especially the tables and the DDLs and the objects to support the new events. So what we did is we paired Snowflake up with Apache Airflow, and we created 2 DAGs for this automation. The first DAG is called our DDL manager. And what this actually does is that it looks into the schema registry for the Avro schema. It looks for the Avro schema definitions and says, oh, we see that there's a new definition, so I'm going to go ahead and create a raw table in Snowflake. A raw table is very generic for us. It's just using a variant data type. We just dump the whole JSON data there because, as Glenn said, Snowflake is very fast with querying JSON data. And then it goes ahead and reads the definitions this time and creates that structured view on top of that raw table so that our end users are able to query the data easily instead of using all the JSON transposing commands. Our second DAG in Airflow is our dynamic event data loader. Once again, this will look for Avro schema. And if it sees that, hey, there's a new Avro schema, it then says, okay, now I know that there is a new event type coming through our stream. We're going to go ahead and start looking in S3 and copying that data into Snowflake the moment it arrives. So if there's no data, it's still trying to look for it, but in the meantime, it's up and running. So these are the 2 main DAGs that are running in our environment to automate this whole entire process. So how does it look like in action? So this is an example when we pair everything together. So our developers can go ahead and, as part of a build, create an Avro schema as well as an event module for a new event stream. Of course, they have their regular service code that are also checking in as well. They go ahead, push it into Git. and our CI/CD pipeline kicks off. It's not really in this flow, I apologize, but we go ahead, do our testing, and then eventually we get to our deployment step. Once everything is checked off and the build is deployed, you can see right here, Airflow is going to go ahead and find that new schema definition file and goes ahead and creates that table and then creates that view that sits on top of that table. In the meantime, an SRE will go ahead and deploy the Terraform changes to the AWS infrastructure. And what this will do is it will go ahead and, as you can see, spin up Kinesis, spin up Firehose, make sure that the S3 endpoint exists, and it also sets up all the necessary CloudWatch monitors along these components. So with all of this in place, we're ready to start accepting that JSON data all the way from source to Snowflake. So it's pretty simple, and that's why we like it so much. Easy to read, easy to maintain, easy to work with. But of course, there's always things to improve on. One of the big things that kind of shot out right away is that we can definitely automate the applying of the Terraform changes. Right now, that's a manual SRE step, and this is mainly because of a confidence issue, right? It's a newer tech for our company, and we wanted to get some confidence before we start automating all these infrastructure changes in our AWS infrastructure. The second is that we would, in our dynamic event loader, right now you saw all it does is creates that raw table and then place a structured view on top. One of the options we want is to materialize that data. Because even though Snowflake is really fast at querying raw JSON that's stored in the variant data type, we notice that with large tables, we can see 10 to 15% improvement in our queries if we materialized it. So, we wanted to find and try and create a mechanic so we can just toggle an event to say, hey, for this one, let's materialize it. And then lastly, the one other step is that in the Airflow DDL job, this is something that I feel that will be a better fit for Terraform. So that's one thing that I might want to move because it's still setting up and configuring infrastructure for the service. So, yeah. And that's really about it. It's pretty straightforward. So, one more shameless plug. OfferUp is growing, and we are growing really big right now. We just opened a whole new office in Miami. We're based in Seattle. So if there are any data engineers or engineers out there who are interested in working for OfferUp, check us out. Check out our job site. And yeah, thank you for coming. Appreciate it, guys.